All right, so what we're going to do in this lesson is represent a function with a power series. Remember how we did the Taylor polynomials and they were an approximation? But the idea is that if you take it out forever and ever, it'll be the function exactly. What we're going to do is represent a function as that infinite series. So what we want to remember, so this is what we call your geometric series. Sum from n to infinity, a times r to the n. And then if you, this is one where you can actually get an answer. Remember how there were so many that we just said it converges or diverges, but this one we can actually get an answer. So this is what the sigma notation looks like. And this is what the sum of the series is. And when you write it out, it would be a plus, and then a times r plus a times r squared plus a times r cubed. You just keep multiplying by r forever and ever and ever. Do you remember the example we did of the bouncing ball and it bounces to 3/4 of its height each time? You just keep multiplying by 3/4. That was a geometric series. So looking at number one, and I kind of like these. I made the first one really simple, but some of them are sort of like a puzzle where you have to rearrange everything. So it sort of appeals to my puzzle doing nature. But I made the first one match the pattern exactly. So do you see how this is 1 over 1 minus x, how it matches that pattern, literally exactly centered at 0. So a is 1 and r is x. In the pattern, 1 represents a and r is x. So when you go to write out the sigma notation, it's going to be from n to infinity, or 0 to infinity. And then 1 times x to the n. And then we're going to write out the first few terms. So it would start with 1, and then you just keep multiplying by x. So what would the next one be? X, good. And then plus forever and ever and ever. So if you do that forever, infinitely, which don't try to think too hard about it. We don't have the capacity really, but it would be this function. Cool, right? Cool. Okay, now sometimes it's hard to rearrange them so they're in that format though, and that's what these next few are. Sometimes it can be kind of tricky. First thing you need to do is get it centered in the right place. Then you need to make sure that it's subtraction. It's 1 minus r, and then you need to make sure that that's a 1, because sometimes you get a number that's not a 1 there, right? The first thing we need to do is make sure that this one is centered at -1. So I'm going to start with this 1 over 1 minus x. You always start with what you have, and then we're going to manipulate that to get it to, follow what's given in the problem, right? So it's going to be 1 over, and I'm going to leave this off for a second. We want it to be x plus 1. If it's centered at -1, you would need to have an x plus 1. Think about your shifts left and right. You know how it's backwards, where you're shifting something to. So we need to figure out what number goes here so that these are still equivalent. So if you distribute this negative sign, you would have minus x minus 1. So what would need to go here? 2. Good, because you would have 2 minus x minus 1. And 2 minus 1 is 1. It would be 1 minus x. Did you guys all follow me there? Okay. You can always write it out to the side or something to check your work. Now here's the thing. Oh, are you with me? We just saw it, had a light bulb on it. And some of these are kind of tricky like that. You have to do the algebra manipulation. Now the next thing is, it is subtraction. So we have that, because sometimes it's addition and then you have to multiply by a negative. But it needs to be 1 minus r. So I need to fix it so that this is a 1. So I'm going to divide everything by 2, and that will make that be a 1. So it'll be 1/2 over 1 minus x plus 1 over 2. So I literally just divided all 3 of those terms by 2. And now it follows the pattern. I have something over 1 minus r. So a is 1/2, and r is x plus 1 over 2. Yeah, some of them are kind of tricky. You have to do some algebra to manipulate it to follow this pattern. But again, it's kind of like doing a puzzle. I sort of like it. Some of them can be hard though. All right, so your sigma notation from 0 to infinity, it's a times r to the n. So it'll be 1/2 times x plus 1 over 2 to the nth. And then we'll just write out like the first few. You don't have to write out like 10 of them or anything, but like just to get the pattern started. So it would start with 1/2. And then you're going to keep on multiplying by r. So you're going to multiply by x plus 1 over 2 to like keep the pattern going. So what would the next one be? X plus 1 over 4, good. And then multiply by this again. X plus 1 squared over 8. Good, we'll do one more. X plus 1. Good. It's just to generate the pattern so you can see what's going on. All right, so for number 3, again, you always start with what you have, except I would probably write this around the other way, 4 over 2 plus x, because we want that variable to be at the end eventually once we're done rearranging this. So first thing is make sure it's centered at the correct place. This one says centered at 0, and we're good because it's just an x. So we're good as far as that is concerned. The next thing is this has to be subtraction. It has to be 1 minus x. So I'm going to multiply every, oh, go ahead. For sure? You can't. No, because the x doesn't have a 2 with it. Yeah, it has to be all 3. So I just multiplied every single term by a negative. You're like, hey, you just made them all negative. Yeah, well, at least now I have the subtraction part of the formula. And then the last thing is this needs to be a 1. It has to be 1 minus x. So how could I turn that into a 1? Divide everything by -2. So in the numerator, if I divide that by -2, it'll just be 2. This will be 1 minus x over -2. Yeah, oh, you're ahead of me. What's A? 2, good. And R is 2. Yeah, and I'm just going to put the negative out front. You could write it as -1/2 x, you know, however you want to write that. So your sigma notation, we're going from 0 to infinity. It's A times R to the n. Watch me with these negative signs. That's my struggle. I'll just make everything positive. And this one's supposed to alternate. So just look after me. If I mess it up, please yell at me. All right. So we're going to start with 2. And then you just keep multiplying by -x over 2 to generate the pattern. So the next one would be -x. And then if you multiply that by -x over 2, it'll be plus x squared over 2. Let's do one more. The next one will be minus, we're good, and then plus infinitely more terms. All right, so this one, first thing I'm gonna do is like write it the other way. Well, you know what, maybe we'll center it first and then I'll flip it around because it's gonna have to be something minus x. So the x is gonna have to go around, but you know what, this one's actually really weird. Let's center it first. So 5 over 2x minus 3 equals, again, you always start with what you've got because you want to make an equivalent statement. So to center it at -3, it would need to be x plus 3. It's always the opposite. You want to think of like the left and right shifts. They're always backwards, I know. Now you can't go around like changing it. These things need to be equivalent. So this would be 2x plus 6. But I need for it to still be 2x minus 3. So what would I need to put like at the end of this to make it still be the same? Because this would be 2x plus 6, but I need for it to still be a minus 3. Minus how much? 9, good. Sorry, I just didn't hear you. Okay, so we centered it at the correct place, so good. Now I'm gonna, oh wait, what?
I was thinking of the name.
Oh, I know what you're talking about. Oh, because you have to adjust whatever that is. Yes, it's exactly. And I taught you that. Yes. We remember something from 2 years ago. That's awesome. Because I teach that topic the exact same way. I'm like, you have to still, I tell you, you have to maintain the integrity of the problem. You have to keep it whatever it was. So that's exactly what we're doing. That's awesome. Okay, now I'm going to flip it around because again, we're going to have it be like something minus whatever. So I'm going to put this as 5 over, what is this? -9 plus 2x plus 3. I didn't really do anything there besides like write it the other way. I put the -9 out front. And then I would multiply everything by a negative because it's going to need to be subtraction. It would be -5 over 9 minus 2x plus 3. So again, you want to get it centered first and then make it subtracting. And then I have to change that 9 into what? It needs to be a 1 because it has to be 1 minus r. So how would we do that? Divide by 9. So sometimes it looks really messy. Like that's going to be a -5/9 over 1 minus all of this over 9. But it's fine. Like, and that's going to be what r is. Like, that's just what it came out to. And some of them are messy, you know. So a is the -5/9. And r is the 2x plus 3 over 9. It is a lot of algebra. And you have to really be like creative with how you manipulate it to get it to turn it. But you're just looking for it to be that pattern. Again, I view it very much like puzzle doing. That's like, it kind of appeals to me with like the puzzle doing part of my brain. Like, oh, I have to turn this into that. Okay, just move stuff. So sigma n is 0 to infinity. And again, it's a times r to the n. And I just want us to list out like the first few terms. So the first one will be -5/9. And this isn't going to alternate. Actually, every single term is going to be negative here because that negative that's out front. So you're just going to multiply that by r. So let's see, if you multiply that by 2/9, that'll be 10/81. And then the x plus 3. And then again, minus, because they're all going to be subtracting. What would the next one be? You have to multiply by 2/9. So 20 over 81 times 9, 729. And then x plus 3 squared. That's far enough. First of all, I ran out of room. And second of all, I don't want to do 729 times 9. Do you guys want a brain break before we do the other side, or do you want to just keep on going? Brain break? Okay, take like a 2-minute break. Okay. Like, okay. So looking at this one, with all the examples we did on the other side, I kind of centered them first. This one's a little weird though, because it's sort of just an x there. So I would take care of the negative first. Like you need it to be subtracting. So we're going to take this 1 over x. It's nothing minus x, but you're going to need to make that be a -1. Like I multiplied them both by a -1. You don't have to write the 0. I just did to show that there should be something there. Like we want it to be something minus something. And then we want to center it. So we want this centered at 1. So what is this going to have? X minus 1. And then you have to figure out what goes here to maintain the integrity of the problem. We still need it to be 0. So this would be, if you distribute the negative, it would be minus x plus 1. So, well, not a 1, but this is negative x plus 1, but I need for it to still be 0. So what would need to go here? -1. There we go. Good, so that it cancels out. This one's tricky with the negatives. That was kind of a lot. Here, let me show you, and then I'll erase it. Just watch. This would be -1, and if you distribute this negative sign, it would be minus x plus 1, and then these cancel. You would have nothing minus x. So we still, we're all together. Okay. I would probably just like work that out off to the side just to check, because it is weird with the negatives. All right, now here's the thing. It needs to be a 1 minus whatever. So we're going to go through and divide everything by a negative. So this will be +1 over +1 minus x minus 1 over -1. Or I guess you could put a negative in front of that instead of making it a fraction. Let me do that instead. So what is A for this one? 1, good. And R is negative. I would leave it like that. I guess you could distribute the negative if you want, but I think it's better if it's factored, because remember, we're going to multiply by that every single time. And I think it's better if you just leave it alone like that. So your sigma notation from n is 0 to infinity, and then it's A times R to the n. So it'll be 1 times this whole thing to the n. And we're just going to list out the first few terms just to like generate the pattern. So the first one's 1, and then you multiply by this. So it'll be minus x minus 1. And then you multiply by this again, so it'll be plus x minus 1 squared. And then what will the next one be? If you multiply by a negative x minus 1. Cube, good, and then plus forever and ever. So number 6 and 7, I'm going to show you how you can do the same thing, even if it doesn't follow a geometric pattern, because you'll notice all the ones that we did so far, they were all geometric, right? It's like, well, how would you do this if it wasn't geometric? You fall back on something that is geometric. You figure out a way that you can use something geometric to get what you want, okay? So it says find a power series for ln of x. Well, what's the one we just did? 1 over x. Any relationship between those? Yeah, so the antiderivative of 1 over x gives us what we want. So if we do the antiderivative of the one we just found, we're going to get what we want. And we did the derivatives and integrals last lesson. That was the last thing that we did. So we're going to do the antiderivative of this right here. So sigma n is 0 to infinity. I'm going to sort of just ignore that 1. And then how would we do the antiderivative of this? Or you know what? I'm trying to think. Let me rewrite that really quick. Before we go and do this, actually, I guess I didn't need to erase that. Let me rewrite that, because actually it's not wrong, but let me just rewrite it. It would be -1 to the n, and then x minus 1 to the n. Does that make sense? Like, let's think of it that way instead, because that's going to make that a little bit easier. Because yeah, it's like, what is that antiderivative? So the -1 to the n will just sort of be there. There, that's a little bit easier. Let me throw that question at you. What would be the antiderivative of this part? Good, you're going to raise the power x minus 1 to the n plus 1 over n plus 1. Perfect. Yeah, because I realized when I asked you that and then I looked at it, I'm like, huh, that's a little bit weird looking. But do you see what I did there? I just put the -1 to the n and then the x minus 1 to the n. I just kind of wrote it separated, because then the -1 to the n, that's just what makes it alternate. So this is really the only part you have to worry about. All right, so we're going to start with n being 0. If you plug in 0 for n, this is going to be positive x minus 1. And then if you plug in 1 for n, it's going to be negative. That's a Taylor polynomial. Here, we're just doing an antiderivative. So we raise the power and then we divide by that. It does look like that though. So this would be x minus 1 squared over 2. And then plus x minus 1 cubed over 3. And then minus, so on and so forth. And then the last one's going to be really similar. And they do this on the AP exam. Like, they'll give you 1 and then ask you to do something with something else, and it'll be the derivative or the antiderivative. So we're given this function, or it says, I'm sorry, find a power series for this function centered at 0, given that 1 over x plus 1 is this. So the derivative of 1 over x plus 1 would be what? If you do the derivative of this one, you get, yeah, like, are you following me there? Like -1 over x plus 1 squared. So if you do the derivative of this one, you'll get what you want. d dx is the derivative. So the derivative of the one that they gave us will give us the one that we want. So the -1 to the n, that's just what's going to make it alternate. And then what would be the derivative of this part? N and then x to the n minus 1, which actually that is going to make us need to start somewhere different. We can't start at 0 because if you plug in 0, you're going to get a -1 there. So we're actually going to have to start this at 1. We did the derivative of x to the n. Yeah, it's the same as we did the antiderivative of this one. We just did the derivative of that one. I was doing one of each as an example. All right, so listing out the first few terms. Your first term, if you plug in 1, it's going to be -1. The rest of that's gone. -1 plus, and then if you plug in 2, you will get 2x. And then if you plug in 3, it'll be negative 3x squared plus so on and so forth. So again, if it's not geometric, you can fall back on something else. And they love to do this. They love to give you one and then ask you to like manipulate it some way. So they'll have like a given thing and then ask you to change it in some way, or like use that one to get the truth.